Hello and welcome back to Solving for Solh. Today we're evaluating powers with negative bases. So if you've had any trouble or questions with evaluating how to deal with negative bases, this is the perfect video for you. I'm gonna go over all the rules and then we're gonna solve some practice examples to make sure you understood the concepts perfectly. This is the rule. Let's say we have a, which is the base, and n, the exponent. A is an integer, n is a natural number. If a is greater than 0, then 8th power of n is greater than 0. And if a is less than 0, then 8th power of n is greater than 0 if n is even, and 8th power of n is less than 0 if n is odd. This might sound a bit confusing, but it's easy to understand once you see it with numbers. So let's say we have 2 to the power 5. 2 is greater than 0. Therefore, 2 to the power 5 is going to be greater than 0. Now we have negative 2 to the power 4. Negative 2 is less than 0. And then you look at the exponent. 4 is an even number. Therefore, negative 2 to the power 4 is gonna be greater than 0. Finally, let's look at negative 2 to the power 5. First, look at the base, negative 2. Negative 2 is less than 0. Then 5, which is the exponent, is an odd number. Therefore, negative 2 to the power 5 is gonna be less than 0. So let's break down these examples to understand why this happens. So for negative 2 to the power of 4, you break it down, it's negative 2 multiplied by negative 2 multiplied by negative 2 multiplied by negative 2. So once you multiply negative 2 by negative 2, you'll get positive 4 multiplied by negative 2 times negative 2. Once you multiply that by negative 2, you'll get negative 8. And once you multiply negative 8 by negative 2, you'll get positive 16. So an even exponent gives us a positive number. Now let's look at negative 2 to the power 5. So for negative 2 power of 5, we'll have negative 2 multiplied by negative 2 5 times. Therefore, once we expand it, it's 4 multiplied by negative 2 gives us negative 8 multiplied by negative 2 multiplied by negative 2. This will result in positive 16 multiplied by negative 2, which would give us negative 32. You see, an odd exponent gives us a negative number, while an even exponent gives us a positive number. Now, let's apply the rule we just learned on these questions. So, we have for A, negative 3 power of 15. First of all, you look at the base, negative 3. Negative 3 is less than 0. So now that we know that the base is a negative number, we look at the exponent. 15 is an odd number. Therefore, negative 3 power of 15 is going to be less than 0. B, negative 2.8 to the power of 8. Negative 2.8 is less than 0. Now let's look at the exponent. The exponent is 8. 8 is an even number. Therefore, the number is going to be greater than 0. Finally, let's look at C, where we have negative 14 to the power of 22 multiplied by negative 103 to the power of 17. Let's look at each one alone. So, for the first one, we have negative 14, so it's less than 0, and the exponent is an even number. Therefore, this is going to be greater than 0. And the other side, we have negative 103 to the power of 17. Negative 103 is less than 0. So we look at the exponent, and 17 is an odd number. Therefore, it's gonna be less than 0. So, due to one side being negative and one side being positive, once you multiply them together, the final result will be less than 0. Now, let's solve some examples so that we make sure that you understood the concepts. Starting off with this question, where you have to write in the form of a single power, then simplify if possible. So, starting off with A, we have negative 3 squared multiplied by negative 7 squared. The first thing you need to look at is the base. The base is negative for both sides. Now you look at the exponent. The exponent is an even number. 2 is an even number. Therefore, we know that the end result is going to be positive. To simplify this, we take what's in common outside, which is the power of 2, and we multiply negative 3 by negative 7, power of 2. This will give us 21 power of 2 and a positive number, as you can see. Moving on to part B, where we have 1 over 2 power of 4 multiplied by 4 over 3 power of 4. Like last time, we look at the base first. So we have half, which is a positive number, and 4 over 3, which is also a positive number. Now we look at the exponent. Both of them are 4, which is an even number. Therefore, we know that the result is going to be positive. So we take the 4 outside and we have 1 over 2 multiplied by 4 over 3 power of 4. To simplify this, you can cross simplify. So 2 and 4, here you get 1 and here you get 2. That's a trick if you didn't know it. Now that's easy to simplify. You have 1 multiplied by 2 over 3, which is 2 over 3, all to the power of 4. Now that we have that covered, let's move on to part C. For part C, we have negative 2 power of 3 multiplied by 5 over 2 to the power of 3. Let's begin by looking at the base. So we have a negative base and a positive base. With a positive base, we know that's going to give us a positive number. Now the negative base, we have an odd exponent. 3 is an odd number. Therefore, the result is going to be a negative number due to the fact that we're multiplying a negative number by a positive number. So let's simplify. We take the 3 outside and we'll get negative 2 multiplied by 5 over 2 all to the power of 3. Simplifying this is really simple. The first thing you do is you turn the negative 2 into 2 over 1. So it's easier to understand. And now you cross simplify. So 2 by 2 becomes 1 by 1. By doing so, you'll get negative 1 over 1, which is 1, multiplied by 5 over 1, which is 5. Negative 5, all to the power of 3. And as we know, 5 to the power of 3 is 125. But due to 3 being an odd number and the 5 being a negative number, we'll get negative 125. Hopefully you're solving along and you're doing well. Now let's move on to part D, where we have negative 3 over 5 all to the power of 4 and all this to the power of 5. So this looks complicated, but let's break it down so it's easy to understand. So D is equal to negative 3 over 5 all to the power of 4, and this all to the power of 5. To break this down, we'll first have to look at the base. Negative 3 over 5. So it's a negative number. It's less than 0. Now we look at the first exponent, the 4. Since 4 is an even number, we know that we'll get a positive result. and positive to the power of 5. Hmm. The first thing we need to do is look at the base. We have negative 3 over 5, which is a negative number. It's less than 0. So the next step is to look at the exponent. We look at the first exponent, not the 5, the 4. 4 is an even number. Therefore, we know that the result is going to be a positive number. And because we know that what's inside the bracket is now positive, the 5 won't have any effect on the sign. However, if it was negative 3 over 5 to the power of 5, all to the power of 5, then the result would have been negative, since 5 is an odd number. Therefore, it would have produced a negative result. So now that we know that the final result is going to be positive, we can just simplify it by writing it in the form of d is equal to negative 3 over 5 all to the power of 4 times 5, which is 20. And even if you look at it this way, 20 is an even number, therefore the result is going to be positive. Moving on to part E, where we have negative 2.1 multiplied by negative 2.1 squared multiplied by negative 2.1 to the power of 3. The first thing we need to look at is the base. So it's negative for all the numbers. Now let's look at the exponent. So for the first one, it's 1. 1 is an odd number. Therefore, we know that negative 2.1 is gonna stay negative. Multiplied by negative 2.1 squared. 2 is an even number. Therefore, we know that this number is gonna yield a positive result. And finally, negative 2.1 to the power of 3. 3 is an odd number. Therefore, it's gonna yield a negative result. So, negative positive is gonna yield a negative result, and negative negative is going to yield a positive result. So the final result is going to be positive. Now we can simply simplify it by writing it as negative 2.1 to the power of 1 plus 2 plus 3, which is negative 2.1 power of 6. And as you know, 6 is an even number, therefore we know for sure that the final result is going to be positive. So here are the answers for the first part. Save them if you want, because now we're gonna erase them and work on F, G, H, and I. Starting off with part F, where we have 3 over 5 all to the power of 7 multiplied by 2.1 all to the power of 7 over negative 2 power of 7. So in order to find out the sign of the final result, we need to look at the base. So 3 over 5 is a positive number. Therefore, this is going to yield a positive number. 2.1 to the power of 7, 2.1 is a positive number. So till now, we know that the numerator is going to be positive for sure. Now let's look at the denominator. So the base, negative 2, is negative. Therefore, we need to look at the exponent. 7. 7 is an odd number. Therefore, we're going to get a negative denominator. So let's start simplifying it. First of all, in the numerator, we have 3 over 5 power 7 multiplied by 2.1 to power 7. Both of them are to power 7, so we can take the power 7 outside. So we'll get 3 over 5 multiplied by 2.1 over 1 power 7 all over negative 2 power 7. By simplifying it further, we get 3 multiplied by 2.1 is 6.3. And 5 multiplied by 1 is 5. So we get 6.3 over 5 all to the power of 7. And all this over negative 2 power of 7. Finally, we can take the 7 outside and we'll get 6.3 over 5 all over negative 2 all power of 7. And since we know that 7 is an odd number, the result's going to be negative. Now let's work on part G. So for part G, we have 3 over 5 all to the power of 4, and all this is divided by negative 2 over 5 power of 4. To simplify this, you need to remember a rule where you can transform the division sign into multiplication by flipping over the fraction. Therefore, we can get 3 over 5 all to the power of 4 is multiplied by 5 over negative 2 all to the power of 4. So we flip the negative 2 over 5 into 5 over negative 2, and by doing so, we converted the equation from a division to a multiplication. Now it's much easier to simplify. We can take out the 4 to the outside. We'll get 3 over 5 all multiplied by 5 over negative 2 all to the power of 4. We can cross simplify 5 with 5 to get 1, 1. And finally, we'll get 3 over 1 is 3 multiplied by 1 over negative 2 all to the power of 4. We can simplify this even further and we'll get 3 over negative 2 all to the power of 4. So now we have negative 3 over 2 as the base, which is less than 0. And we look at the exponent, which is a 4, an even number. Therefore, we know that the final result is going to be positive. Now let's solve h and I, which are really simple to solve. So for h, we have a over b all squared and all this to the power of 3 multiplied by a over b. So simplify this, you get h is equal to a over b all to the power of 2 times 3 multiplied by a over b. You can simplify this even further and get a over b all to the power of 6 multiply by a over b. Finally, add the exponents and you'll get 6 plus 1, which is 7. So you'll have a over b power of 7. Now moving on to I, where you have a cubed multiplied by a all squared. To solve this, first multiply a cubed by a, which gives us 8 power of 4. So it's 8 power of 4 all to the power of 2. And as you know from the previous video, once we have a power to the power, we multiply the powers. So you'll get 8 power of 4 times 2, which is 8. Now for a quick recap on what we learned in this video. So we learned that if the base is positive, then the result is going to be positive no matter what. And if the base is negative, then we have two options. Either we have an even exponent or an odd exponent. When it's an even exponent, then the result is going to be a positive answer. And when it's an odd exponent, the result is going to be a negative answer. Thank you for watching the video. If you have any question, please don't hesitate to ask them in the comments below. And if you find the video helpful, please leave a like and subscribe down below. For the next video, I'm going to be covering how to deal with negative exponents. Thank you for watching and goodbye.